Hello and welcome. It's still Microsoft Excel World Championship season, and as promised, I'm going to give you a quick walkthrough of how to solve my case from last weekend about the board game Othello. I'm not in training anymore because for the second year in a row, I've been knocked out in the third round. Feeling a little bummed about that. That just happened today, but oh well. Such is life. Can't win them all. Unless your name is Andrew Nye, in which case we don't yet have enough evidence to determine that he cannot win them all. But anyway, I'm not going to dwell on that. I'm going to move on. So this case is about the board game Othello. So a simple game. You play on an 8x8 grid, just like a chess game. You have counters that are black on one side, white on the other, so you can turn them over as they're captured. One person plays black, the other person plays white. Two players take turns moving, and on your move, you can place a counter and capture one or more of your opponent's counters. And the way you do that is you have to complete a line that has one of your counters at each end and then an unbroken string of one or more of your opponent's counters in between, in either a straight line horizontally, a straight line vertically, or a diagonal line. So what does that look like? For example, white's opening moves you could play there, and then you've got one black piece in between white pieces at the end. Or if we go over to this kind of busier board here, white could play over here, and then you've got four black pieces captured in between there, and you've got two more on the diagonal captured in between two white pieces here. And so when you do that, the pieces in between get flipped over to your own color. So again, let's say if you play a white piece over here, you would capture that, and then you'd also capture these two going down there, and you'd capture this one down here as well, because they're all, sorry, wait, would you capture that one? No, because you played up here. Sorry, so you would not capture that one, because that one is in between two existing white pieces, and it's not being newly surrounded by the piece that you've placed. So specifically, these kind of three cells were given as examples of play for white. Yeah, so white cannot play in here because there's a bunch of black pieces down here, but there's no white piece on the other side, so you wouldn't capture anything in that direction. And the other directions you can come out of there, across or diagonally, there's no black piece next to it. So that's not a valid play for white. White can play here, and you'd capture that piece and that piece, because they're both, again, on straight lines, with a white piece at the other end and no interruptions. And obviously you can't play here, you have to play into an empty space. So having said that, let's dive on in. There's a real kind of shift in this case. I couldn't find any way to avoid it. The logic of the game is quite simple to explain to a human, but not very simple to explain to a computer. So we had two kind of easy levels that were just, making sure you're comfortable working with the tokens, and then we had the real meat of it, which is levels 3, 4, and 5. So let's start here. First question is, how many black and white pieces in total are there on the board? Lots of different ways you can do this. You can do count if this. You could use a wildcard character. So wildcard just saying it has to be one character long exactly. You could do 64, which is the total number, minus count blank. You could do sum of count ifs of this, where you're counting each of those two, and you could either just leave that as a locked reference, or you could press F9 to convert it into symbols. There's a bunch of other ways you can do this, but anyway, you get the idea. So you fill that down, that's fine. Then the second question is how many black pieces on the board. Main thing here is just helping you to realize that it's not conditional formatting, they're actually different characters here. So in other words, you can just say count if this, and again, I'm just going to point at one and then double click it, press F9. Whoops, there I am. Function key, press F9, and close out, and copy down. So like I said, first two levels, pretty straightforward, just get comfortable with the board. And sorry, I guess I should have said, so the board is obviously an 8x8 like this, but just for the purposes of being able to lay out individual levels, the board just comes spread out into one thing. So the rest of the levels then ask about moves. So first it says, here's a board, here's a square. If white plays into that square, is that a valid move? Then we take it kind of the next step further. These are valid moves. If white plays into there, how many pieces does it capture? And then it kind of takes it next level further than that, which is what's the square you can play in that will capture the most pieces. So for all of these, I'm going to come out onto a separate tab. I will say, there is a way to kind of tackle this without rewrapping the board up. And I recommend, if you want a sort of hardcore approach to this, take a look at Excel Wizard's video. I think he did a speed run of this in maybe 3 minutes, or this entire case, with some amazing amazing formula work. If you want to up your advanced formula game, as a channel I cannot recommend too highly. He's fantastic. But I'm going to try and do something a little bit different, which is I'm going to try and motivate this in as sort of human friendly a way as possible. In other words, I'm going to say, okay, we're going to start off by just wrapping the board so we can look at it, and then we're going to think about it as I think a person might think about it, and try to convert that into formula logic. So first thing we're going to do is just have a game picker. Sorry, there's example 3, A, B, and C. So I'm going to look up this in column B, and now you can see it's selected a bunch of columns because they're merged cells. So I'll just turn that back to column B, and then returning from these columns here. And then I'm going to use wrap rows to wrap that in rows of size 8. And that gives me the board, and I'll just copy some formatting from over here to make it look a little bit more like a board. So this is now kind of human style what we're working with, and then we'll also look up this to figure out what square we're specifically interested in. So again, B, and then returning from G. So we're interested in this case in A1, and I'll actually just bump this over here so that I can bring in the labels from here. Just center them. And here. Okay, so now in this case I'm interested in A1, so let me just do a little bit of conditional formatting. New rule, and I'll say equals this and this equals this. Sorry, lock that, and then format. What am I doing? Fill. Yes. Just turn it yellow. Okay. Try again. Sorry, that should not be $1 there. It should be $C$4, not $C4. Okay. So now, basically, what you'll see happen is if I change example 1 to example 2 to example 3, all the examples for this level have the same board in just different positions. But then if I change to, where are we? I think we're on 30s. Yes. If I change to 31, you can see this is where we're interested in. So in this case, you can see right away. Okay, well, that cell is not blank, so you obviously can't play in there. By the way, one of the challenges with this case is because of the gap between the ease of human comprehension and the relative challenge of machine comprehension. I know a lot of people did just tackle this case manually by doing basically what I've done so far, and then manually working out the answers. Just putting in, okay, 33, let's see, can't play there. 34, let's see, can't play there. 35, let's see, oh yeah, you could play there, you'd capture that. And just going through it that way, which I did say to Andrew when I sent him the case idea that it was a risk, but I couldn't find a way to get rid of it without making it extremely difficult. I might talk a little bit about the end about how I had considered it making it extremely difficult, but that's not for now. Anyway, so the idea is, given, let's just pick a random example. Given, I want one that's not on the corner. Just, I don't know why I just do. All right, so here, given this one, we're interested in looking in all the 8 different possible directions from here. So up and to the right, right, down and to the right, down to the left, left, and up and to the left. In each of those directions, we want to figure out, do we see the pattern that we need, which is black, 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 white. Some number of blacks followed by a white. So in this case, we do in this direction and we do in this direction. So here's how I'm going to do it. First, I'm going to think about my thing in terms of x and y coordinates, right? So the x coordinate is going to be, it's in column 7, and the y coordinate is going to be, it's in row 2. So I'll just do that as x start, and I'm just going to say you know, I did a video with lots of code and car. Let's do it a different way this time. Did a video this week, I should say, with lots of code and car. Obviously not giving up on code and car forever. And then y start. And that's just going to be mid this. Give me the second character of that. And because the board is only 8 characters wide, you don't have to worry about double digits or anything like that. So that's the starting x and y coordinate. So then you think about, let's say, going down from there. Then you're going to be interested in your x coordinate is going to be 7 all the way along, because you're going to stay in column 7. And then you're going to go 3, 4, 5, 6, 7, 8. At some point you'll go off the board, so then your next one would be 7, 9. You can never go more than 7 squares in any one direction, because you start here, 7 more in that direction, that's the last square on the board. 8 squares more, you're off the board. So you think about, okay, so these are the coordinates for going down from there, and then you could say index on this board. Right, still waiting for them to change it so that when you select a dynamic array and then press F4, it locks the dynamic array. It doesn't do that at the moment. It makes me sad, but I'm sure it's coming. Anyway, so we're going this many down and this many across. As a mathematician, it always troubles me a little that that index takes the arguments not in XY order for coordinates. But anyway, so then you can say, okay, so going down, you get black, 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 white, and that's the kind of pattern you want. And then you could concat that together. You get that, and then you could use a text before to figure out what comes before the first white. I'll just, again, take this and then hard code it. And then, sometimes that'll give an error, sometimes it won't. And then you can just, you basically want to figure out, is this thing that's left before the white, is that all blacks? Now, one little thing, I'll talk about how to kind of generalize from this totally manual setup in a second, but one little nuance here is, let's say that, see, because I've been so diligent with my formula, I can't even edit one cell erroneously, but let's just, sorry, now I have to unmake it a dynamic array because I've copied and value pasted, but I'm just going to fudge this for a minute. Okay, yeah, so I was going to double check, was it going to give me something or just an empty space when there was a blank there? But it looks like the answer is it will give me a 0. So then I would be able to say this is not all blacks, it's some blacks and some zeros. So, okay, that's a quick aside there. All right, so that's basically the idea. Then if you want to figure out, is this string all blacks? I had one way that I thought of doing it, which was you can work out the length of that string. Then you can create a string that is that many black characters long by using the repeat function. So repeat this character that many times. Again, just convert that. And then you can just say, is that equal to that? And here you get true because it is all black bullets. Or the other way, the way I saw Bo do this in his video, which I thought was quite clever. You substitute this, replace black token with nothing, and you just check, is that equal to double quotes? And if it is, you're done. So that's the sort of idea of how to figure out, for a given set of coordinates, does the thing that you get to along those coordinates match the pattern, which is some number of blacks followed by a white? So now the question is, how do we generalize the set of coordinates? And the way to think about that is, let me just, can I pull in the arrows quickly? Yes, I can. I have them here. So let's, oops. Drop them all in there. And then let's, I'm just going to split them out. I'm going to say mid this sequence, comma 8, 1. So I'm just going to think about my x change and y change for each one of these. So if I'm moving to the right, again, my x is left and right, so this is going to be +1 and this is going to be 0. So in other words, in each stage, I'm going to add 1 to my x and add 0 to my y. If I'm going up and to the right, I'm going to add 1 to my x and subtract 1 from my y. If I'm going up, 0 minus 1. If I'm going left, minus 1, 0. If I'm going, oops, sorry, minus 1, 0. if I'm going down and to the left, that's going to be decreasing x and increasing y. If I'm going down, that's going to be that. If I'm going, it's going to be increasing them both, and this is going to be decreasing them both. So now I've got my 8 different possible directions. So then I can calculate my x shift. That can just be all of that times sequence 7. So these are all the different shifts. In other words, this is 1 step away, 2 step away, 3 steps away, 4 steps away, 5 steps away, 6 steps away, 7 steps away, the x coordinate in each of these 8 directions. And then I can do the same thing with my y shift. And that's just going to be this part times, again, sequence 7. Because, again, the most steps you can go in any direction is 7. So now I can say, okay, so what is my x coordinate? You could kind of squeeze all this back down, because these are dynamic arrays. You can do this as just like a let and add together with other things. But I'm just going to spread it out for now because I think it's a little easier for a human to understand. So you start at 7, and then you add each of these. So, if you're going, let's just copy this over here. If you're going to the right, then your next coordinate is 8, 9, 10, and obviously after 8, you're off the grid, so there's no more. And then similarly, the y coordinate is your y start plus your y shift. So then the next thing that you're interested in is what is the token at each of these intersections. And so what you can say is, let's just say if I'm going to do 4 checks, I need to check if the x coordinate is greater than 0, the x coordinate is less than 9 or less than or equal to 8, and then same thing for the y coordinates. So I'm just, you can't do, importantly, you can't do an and if you're going to refer to the whole range together, because then it'll and together not just the 4 pieces for each cell, but also it'll and together the entire range and just give you one single true or false answer. But the alternative to doing and, which is more dynamic array friendly, is multiplying conditions together. Because when you multiply the conditions together, if the condition works out as true or false, and you multiply it together, Excel says, okay, you're trying to use this as a number, well then I'm going to treat true as 1 and false as 0. And then if you multiply a number of things together, if any one of them is 0, that zeroes out the whole product, and you only get a 1 left at the end if they are all true. So having said that, I'm going to say if this is greater than 0, let's just come up here, times that is less than 9, times the same thing for down here. Then index, in other words, then go over to the board and get me what's in these positions. That, again, first it's y, and then it's x. And then if I'm not on the board, then just give me an x, just so that I can see it visually. So now you can see, if I go set off from the given location, which is this G2 in this case, if I set out from there, going to the right, I come across a blank and then the edge of the board. If I go up and to the right, blank and edge of the board. Straight up, blank and edge of the board. And you can come over here and you can see that's right. You go to the right, blank edge of the board, blank edge of the board, blank edge of the board. And then going to the left, we should see white, black, 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 blank, blank. And then edge of the board, and going down, we see black, 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 white, and so on. And sure enough, we do. So here going left, we see white, black, 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 blank, blank, edge of the board, and so on down. So then what we can do is we can concatenate each of these. And then for each of them, we can say text before. We want before the first white. F9. And you can see there's some NAs because in some directions you don't hit any whites, which is fine. Just noticing that this sorry, so I did a kind of pause and an aside earlier where I was worried about these coming out as empty strings so that I wouldn't be able to identify if there were gaps. And then for some reason they were coming out as zeros before, but now they are coming out as empty strings again. So small fix for that is, well, a few different ways to fix it, but I think the shortest one is I'm going to do this. I'm going to say, when I bring back this XLOOKUP, I'm going to add a single space to the end of that, and then I'm just going to take the left of that. So in other words, if there is any character here, then adding a space and then just taking the left one is just going to return that same character. But if there's no character there, then I add a space, then take the left of that, it'll give me a space. So it just means that all these blanks that were empty strings are now going to be a single space. And that means when I come over here, I'll be able to see the difference. Let me find an example. There's not one that really works here, but so yeah, here for example, you can see it in this string. It goes white, black, black, black. Then it doesn't go straight to the X. There are blanks there. Anyway, so that's that. Then so for that text before, if not found, which is the last argument, I'm just going to say NA. Oops. Okay, so then my test is going to be if the length of it is 0, in other words, if it's one of the cases that's just, hits white immediately, so the text before that is nothing, then it's false. I don't have a valid move in that direction. Otherwise, I want to say I'll do my test. So I'll do it the bow way, because it actually is kind of nicer. So I'm going to replace all the black characters with nothing and see if that is empty. And I just copy that across. So you can see it doesn't work to move right, doesn't work to move up and right, doesn't work to move up, doesn't work to move left. It does work to move down to the left, it does work to move down. So that tells me this is a valid move because there are things you can capture going in that direction. And then you can also work out how many things can you capture by just saying if that, then len of that, oops, otherwise 0. Carry that across. And so finally then, we're going to say, pull it all together. So I haven't done a check in here to see, is the space itself empty? So I'm going to do that first. So I'll say if index this, my y coordinate, then my x coordinate is equal to a space. In other words, it's an empty one. Then n, because we're interested in yn for is it a valid move or not. Otherwise, if any of these is true, if there's a valid move in any of the 8 directions, so I'll say if or all of that, then yes, otherwise no. And so that's going to tell me, is there a valid move? Then the second question asks, how many things can you capture? So just from that, we can answer the first, or the third and fourth levels. So we'll do 40 things starting from 31. And the column input cell is going to be this guy up here. And then we'll hit calculate, and then we'll take this 31. Wait, was it starting from 31? Yes, it was. 31 down as far as 50. Copy it and link in here. Oh dear, getting it wrong. That's a bad sign when you're getting your own question wrong. All right, let's take a quick look at 31. Manual check. Oops, all right, 31. Okay, it should definitely be a no. Why isn't it? Oh, sorry. Yeah, okay, because I did this the wrong way around. If it is not a space. Okay, so try again. Yes, that's better. Now the answers are correct. That's slightly embarrassing, but never mind. These are the mistakes we make. Incidentally, that's, sorry, started too far. Incidentally, that is why you get given the sample answers to check on, which I haven't done here because I've kind of already done this before. But if I had checked it on here, I would have very easily seen, okay, on this one where I'm trying to play into C1, which is occupied, it would have given me a yes, it should have been a no. So that's an easy check. Anyway, okay, so that's those two levels. And then for the last level, you have two choices. You can either, like I said, you can condense a lot of this formula here. You can, if you want, you can basically mash this all down into one cell as Bo did, or you can mash it down to pretty close to that. And then you can just, you know, calculate that one cell here and spread it out to a grid of 8 by 8. Or the alternative is you can do a 2D data table. So I'm going to do that option here. So I'm going to take the sum again. And then I'm going to say sequence. So I've got 30 options in the last level, starting from 71. And here I'm going to take all the different possible input values. And then I'm going to ask it to tell me if I made the row input go in there, and if I made the column input go in here, what would become of this? And that takes a little while to calculate, but not too long. And then we want, sorry, I want to go across the rows, not down the columns. So for each of these, we want to find the max. And then we'll do a check just to be safe. We'll say countifs. How many of the max is there? And the answer should be 1 because we're told that there's a unique maximum. And then if there is, then we can say x match this, sorry, no, x lookup this in here. Default is exact match, and there's only one match, so that's the way to do it. Then we just lock in this. We copy that down. It says there are multiple maximums here. So I've got my own problem wrong yet again. All right, but again, this is the kind of check that lets you debug. So let's go to 72 and see what's going on here. So there's no x start and y start here, but that's fine because I'm plugging in other values. So for 72, what is the alleged maximum is 11. That's a lot to be able to capture, but okay. Here we are. So D4, E4, and F4, according to this, can all capture 11. But that's very disappointing because those are all occupied. What? Maybe my 2D data table approach isn't working? Oh, this is disappointing. Very disappointing. Okay, well, I'm just going to break my earlier workings. I'm going to break my earlier workings and just plug it in. D4. Oops, sorry, back up here. D4. Should most definitely, okay, sorry, I see the problem, I see the problem. I haven't done the check. So what I should do is if this is equal to y, meaning there's a valid move, then give me the sum. Otherwise, do not give me the sum, give me 0. And then we recalculate, and now hopefully we will only have one match for each one, and we do have only one match for each one. So hopefully now those are the right answers. So, well, you can see that I've stumbled quite a bit, even though this is my own question, and I wrote it and designed it, but I've eventually wound my way to a complete score. And hopefully that gives you at least some sense of how you might think of it from a sort of more getting from a kind of human thinking about, okay, so I go down this way and I go across this way and I go across this way, to, how can you turn that into a systematic approach? Anyway, that's all I got for tonight. Hope you enjoyed it, and thanks for watching. I'll see you next time. Bye-bye.